Pressure testing and leak searching, it's not a fast process, and don't fall into the trap of feeling like you have to hurry because it's taking so much time and the customer's on your back, your boss is on your back. So what's some situations we're going to be pressure testing in, and why is it so critical with a VRF? First, it comes back to just, we think we got a low charge. If you think you have a low charge issue and you're losing refrigerant, you need to figure out where it's going. The other side of it is, you may not have realized you had a problem. Maybe you took the system down to do a repair and you just did a quick test just to make sure that everything was okay in terms of pressure, and then you turn around and started to try to pull a vacuum on it and figured out you couldn't. Assuming I have a system that's already fully recovered and maybe I've done some repairs to it and I'm just looking to do a base pressure test, bare minimum I'm going to do is get 300 psi of nitro in it. And it's even better, sometimes I'll take the time to actually pull a slight evacuation on the system to get some of the atmosphere out. That'll improve the accuracy of the test, but it's not dramatic, especially if you know how to adjust for your temperature changes in terms of ambient. That's going to have just a slight fluctuation in your pressures. And I'm going to let that 300 psi stand for at least 12, ideally more like 24 hours before I do anything in terms of starting to pull an evacuation. Now, I do want to clarify that if you're doing a commissioning especially, the manufacturers want to see a 500 to 600 psi pressure test done for 24 hours. So if you're working on a commissioning, don't skip that step. Don't do the 300 thing. A 300 thing is for a system's already commissioned. I'm not overly worried about leaks throughout the rest of the system because I've got history with this unit. I've got a little trust with it. I know that I had a specific failure and I'm just trying to address that one thing. Not everybody agrees with me on this, so this is where you've really got to make your own decision. There's a lot of people out there that just, it's either minimum 500 pressure test or nothing, and that's okay. Like, I don't disagree with you. I have a slightly different process that, you know, I can use a little less material and not have to carry as much, especially these units are typically located somewhere it's not easy to get to. Now we're going to get into the next phase of this where we had issues with our regular pressure test and now we've got to take it a step further. We're going to have to start pressurizing for actual leak searching. And FYI, I'll throw out there, I am really close to having a VRF tech sheet ready if it's not already out there on the website. So be looking for that. We're going to be producing a couple of them in the initial stages. The chiller ones are also still in the works. So I've put a lot of time into thinking about how to efficiently and effectively do this. And I've come up with two basic levels. The first level is less invasive. It means less downtime for the customer. It's a little less stressful. And that's just using standing pressure. Now, 14A refrigerant should be at a minimum 200 psi under most ambient conditions. You know, that's talking around 70 degrees ambient. So as long as we're at that threshold, we've got a decent amount of pressure in this system. We're going to catch a lot of the leaks, especially a lot of the bad leaks. So if you're able to move through and not have to do recovery, not have to go through that whole process, just use the refrigerant that's in the system, take an electronic leak detector or your bubbles, whatever you prefer, go find them. I recommend doing evacuation mode even for level 1 test, just so that you really equalize all your pressures throughout the whole system and everything's balanced. You know, it technically should be for the most part, but just to be sure, you want that pressure everywhere. My level 2 side of this is, okay, standing wasn't enough. You know, we found some leaks, or maybe we didn't find any leaks at all, but we're definitely low on this system. So with level 2, we're going to be doing a trace gas with the nitro. If I'm going to 500 to 600 psi, which in this situation I am, then I'm going to do 40 to 50 psi of trace gas. Then I'll go from there with nitro up to a minimum 500 to 600-ish. Now you want to be careful. These systems are topped out rated at 600 psi, so like be really cautious with that 600 psi barrier. For sure 550, right in that range. Any leaks that are going to be catchable, you're going to catch. The only things that you're not going to see are the operational leaks. The pipes expand and contract based off of heat, so in some cases you may find that when the pipes are cooled down and the system's been off for a little while, they'll seal themselves up. The only way you're going to get that leak to show itself is to get the temperature of that joint in the pipe just hotter. I want to say thank you to today's video sponsor, which is CSG, Compressor Solutions Group, based out of Houston, Texas. They've also got a shop in DFW serving the Texas area, and they also can provide you compressor service nationally. They're a great group of guys. They've done a really good job with just getting their information out there. They try to really invest into training in this industry and just supporting the contractors. Reach out to Jake with any questions you have. He'll be able to take care of you, be able to help you out. They do full service and rebuilds on screw compressors and semi-hermetic recips. They've been a great friend of the channel. They've been a great friend of mine. I look forward to working with them for a long time to come. I'm a big fan and a big proponent of electronic leak searching, so as much as you can practice that, I think it's really useful. Bubbles are great, but if I can electronic leak search, I will, and I'll use my bubbles for confirmation of whatever leak I'm looking for. So at this point, you've done your pressure testing, you've got all of your leaks figured out, go ahead and fix them. Just address your leaks, and this is an excellent opportunity to address any piping issues that exist. Anytime you have to take the system down or do any brazing to begin with, go ahead and try to fix as much as you can. And ultimately, you're going to be going through the whole system anyway, trying to do a proper leak search, or you should be. You should be going to all the different joints and places and just everywhere. When you're doing that, you should keep an eye out for things you see that you know are problems, whether it be Y branches being backwards or joints not piped properly. Maybe they're too tight or too short on their links. Whatever the case may be, just fix those things. For doing a pressure test, we don't want trace gas in there. That's going to allow way too much fluctuation. And this is another great opportunity that, you could evacuate. We're not talking pull a full evacuation on the system. We're talking about just pull a little bit of the atmosphere or whatever is in there off. Make sure all the refrigerant gases are out. You'll get a much more stable pressure test overall, especially over a 24-hour span. And we've all been there where we had some major weather front push through overnight or something happens, and then it will get you, I promise. Just careful. At the end of the day, it passes the test. Yes. You fixed it, you got it addressed, you're not done. Now you get to go pull the evacuation. That can be an entire challenge in and of itself, given the scale of these systems and the length of your pipe runs. It's pulling evacuations on chillers. It's all just kind of right there, and you're not going hundreds of feet in different directions. And that's where you really got to think about your evacuations for VRF, because the length of the pipe and the size and the scale of the network it's connected to, it's not as simple as just hooking up to a regular old split or chiller and then just starting to pull it down and walk away. And it takes a little more attention to detail, otherwise you won't do it right, and you'll pay for it. You'll pay for it anyway. This is my approach to doing pressure testing and leak search with a VRF system. You need to learn your way. You need to learn what works best for you and your process. Mine is an accumulation of some people I've worked with over the years, in addition to just my own experimentation. Your process needs to be the same. You shouldn't just take one thing that somebody else has taught you, but learn from multiple different people if you can, or as much as you can. Do some experimenting, figure out what works and what doesn't work. Don't go crazy with it. You got to remember, this is the customer's time, this is your company's time, and you've got to be respectful of all of those variables and their material and whatever they've got invested into the job. At the same time, don't fall into the trap of this has to be done right now. Why is it taking so long? Let me tell you, depending on the size and scale of these systems and how hard it is to get access to where we need to go, I've spent days trying to go through one entire piping network because it's in all these different offices, it's above all this drop ceiling. It's a challenge. And that's a crazy thought when you compare it to a traditional split system or even a chiller. It doesn't take that much time to fully leak search a standard chiller for any reason. We pressure test within a few hours. We could pretty well go through the whole thing. It's done. We move on. This is different, okay? I really want to make that clear. This is different. You're gonna spend a lot of time to do it well and to do it properly. Otherwise, you risk missing, and then at that point, it's a matter of can you catch it later, or you're gonna go through a whole bunch of work, get the really obvious ones, miss the small ones that are still gonna give you trouble, and then you've now got to go back and go through all the work again. Hopefully not as a callback, but you never know, just to find the smaller details that you weren't patient enough for the first time. This system takes patience. Patience, patience, patience. It's not something we are good at as technicians. We're not very patient people. If you have an interest, I have tech sheets and tech guides on my website at hvactime.shop. Those are there to just help be a guiding voice and a reference point for you as a technician. You know, not all of us have the ability to comb through all the manuals. Not all of us have all the manuals or the ability to really read them and it makes sense. You know, they're written by engineers, to my opinion, mostly for other engineers. They're not really written in a technical language that the field can easily interpret. Anyway, my point, these tech sheets and the guides themselves, I really try to write from a technician's perspective so that we could easily apply that from our level, not theirs. Either way, MTT, make the time for your family, for your spouse, for your kids. Take care of yourselves out there. I'll see you around.